Hi everyone, I am JULKA. Today's topic is three-dimensional geometry. In part 2, we will talk about straight line. Cartesian equation of straight line passing through x1, y1, z1 and direction ratios a, b, c is x minus x1 upon a equals to y minus y1 upon b equal to z minus z1 upon c. This is the Cartesian equation of straight line. We will explain with the help of an example. Find equation of straight line passing through 1, 2, 3 and direction ratios 6 to 5. Here point x1, y1, z1 is 1, 2, 3 and direction ratios a, b, c are 6, 2 and 5. So the Cartesian equation line is x minus 1 upon 6, y minus 2 upon 2 and z minus 3 upon 5. Next point. Equation of straight line passing through 2 points x1, y1, z1 and x2, y2, z2 is x minus x1 upon x2 minus x1 equals to y minus y1 upon y2 minus y1 equal to z minus z1 upon z2 minus z1. It is similar to the previous formula. Here we put the value of a, b and c, where a is x2 minus x1, b is y2 minus y1 and c is z2 minus z1. We can explain with the help of an example. Find Cartesian equation of straight line passing through 1, 2, 3 and 4, 3, minus 7. Here x1, y1, z1 are 1, 2 and 3 and x2, y2, z2 are 4, 3 and minus 7. Equation of line is x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1, and after putting the value of x1, y1, z1 and x2, y2, z2, we will get the equation of line x minus 1 upon 3 equal to y minus 2 upon 1 equal to z minus 3 upon minus 10. Now equation line in vector form. Vector equation of line passing through the point having position vector small a vector and parallel to b vector is r vector equals to a vector plus lambda times of b vector. We can explain with the help of an example. Find equation of line passing through I cap plus 2j cap plus 3k cap and parallel to 6i cap plus 2j cap plus 5k cap. Here vector equation line is r vector equals to a vector plus lambda times of b. Here a is I cap plus 2j cap plus 3k cap and b vector is 6i cap plus 2j cap plus 5k cap. So r vector equals to I cap plus 2j cap plus 3k cap plus lambda times of 6i cap plus 2j cap plus 5k cap. Now, vector equation of line passing through 2 points having position vector small a vector and small b vector is r vector equals to a vector plus lambda times of b vector minus a vector. We can explain with the help of an example. Find vector equation of a line passing through I cap plus 2j cap plus 3k cap and 4i cap plus 3j cap minus 7k cap. Here a vector is I cap plus 2j cap plus 3k cap and b vector is 4i cap plus 3j cap minus 7k cap. So the vector equation line is r vector equals to a vector plus lambda times of b vector minus a vector. So the required equation of line is r vector equals to I cap plus 2j cap plus 3k cap plus lambda times of 3i cap plus j cap minus 10k cap. Next example, how to convert Cartesian equation into a vector equation or a vector equation into a Cartesian equation. First example, write Cartesian equation of a line having vector equation r vector equals to 2i cap minus j cap plus k cap plus lambda times of 3i cap minus j cap. Here x1, y1, z1 are 2, minus 1 and 1 and direction ratios a is 3, b is minus 1 and c is 0. So the equation of line is x minus 2 upon 3 equal to y minus 1 upon minus 1 equal to z minus 1 upon 0. Say it is lambda. So if we solve third point, we'll get z minus 1 equal to 0 and z equals to 1. So the equation of line is x minus 2 upon 3 equal to y plus 1 upon minus 1 semicolon z equals to 1. Next, write vector equation of a line having Cartesian equation x plus 3 upon 7 equal to z minus 3 upon 4 and y equals to 4. We can rewrite this equation as x plus 3 upon 7, y minus 4 upon 0 equals z minus 3 upon 4. Here point is minus 3, 4 and 3, and direction ratios are 7, 0 and 4. So the vector equation line is r vector equals to minus 3i cap plus 4j cap plus 3k cap plus lambda times of 7i plus 4k. Shortest distance between skew lines. Skew lines are those lines which are neither parallel nor intersecting. They are on different planes. We have two lines, r vector equals to a1 vector plus lambda times of b1 vector, and second line is r vector equals to a2 vector plus mu times of b2 vector. PQ is perpendicular line first and second both, and the PQ is the required distance. Here PQ equals to in mod a2 minus a1 dot b1 cross b2 whole divided by modulus of b1 cross b2. Or we can use this formula b1 cross b2 dot a2 minus a1 in mod divided by modulus of b1 cross b2, because a dot b equals to b dot a. So either we use formula a2 minus a1 dot b1 cross b2 or b1 cross b2 dot a2 minus a1. Now here we want to find out distance between two given lines, x minus 1 upon 2 equals to y minus 2 upon 3 equal to z minus 3 upon 4, and x plus 1 upon 3 equal to y plus 3 upon 2 equal to z minus 6 upon 5. First we rewrite these two equations into vector form. First equation is r vector equal to I plus 2j plus 3k plus lambda times of 2y plus 3j plus 4k. Second equation is r vector equals to minus I minus 3j plus 6k plus mu times of 3i plus 2j plus 5k. Here a1 is I plus 2j plus 3k, a2 is minus I minus 3j plus 6k, b1 vector is 2i plus 3j plus 4k, and b2 is 3i plus 2j plus 5k. First we calculate a2 minus a1, which is minus 2i minus 5j plus 3k. And b1 cross b2 equals to, in the determinants of I, j, k, coefficient of b1 vector 2, 3, 4 and the b2 is 3, 2, 5. After solving determinant, we'll get the value of b1 cross b2, 7i plus 2j minus 5k. Now the modulus of b1 cross b2 is the root of 7 square plus 2 square plus minus 5 square, which equals to root 78. Now the short distance formula is modulus of a2 minus a1 dot b1 cross b2 whole divided by modulus of b1 cross b2. After simplification, we will get the answer 39 by root 78, and after rationalizing we will get the value 1 by 2 multiplied by the root of 78 units. Now the shortest distance between parallel lines. R vector equals to a1 vector plus lambda times of b vector, and r vector equals to a2 plus mu times of b vector. Here these two lines are parallel. So short distance is modulus of b vector cross a2 minus a1 divided by modulus of b vector. Find short distance between lines r vector equal to 2i minus j plus k plus lambda times of 3i plus 2j plus 6k, and r vector equals to 3i minus 2j minus k plus mu times of 3i plus 2j plus 6k. These two lines are parallel because direction ratios are same. Here a1 vector equals to 2y minus j plus k, a2 is 3i minus 2j minus k, and b vector equals to 3i plus 2j plus 6k. Now a2 minus a1 is 3i minus 2y minus 2 plus j minus k, which equals to I minus j minus 2k. And now b vector cross a2 minus a1, determinants of ijk, the coefficients of ijk in b vector is 3, 2, 6, and the coefficient of a2 minus a1 1, minus 1 and minus 2. And after simplification we get b vector cross a2 minus a1 vector equals to 2y plus 12j minus 5k. Now the formula for distance is modulus of b vector cross a2 minus a1 vector divided by modulus of b vector. Modulus of b vector cross a2 minus a1 is the root of 4 plus 144 plus 25 divided by the modulus of b vector is 9 plus 4 plus 36. So after simplification we will get the answer root 173 upon 7 units. This is the distance between two given parallel lines.